So we are starting the next session. We have Dr. Ren over here. The floor is yours, Dr. Ren.
Thank you for the introduction. Good afternoon, everyone. My name is Fengbo. I'm the founder and CEO of Fovus. So it's a great pleasure to be here today to share some insights on how you can accelerate your chem informatics and bioinformatics workflows using Fovus. So Fovus is an AI-powered serverless high-performance computing platform, and we are a HPC partner of AWS. And usually, I would like to get a little bit better understanding about my audience. So I would like to do a quick poll here. Just two quick questions. First one, by show of hands, how many of you or your company are actually running either chem informatic workload or bioinformatic pipelines, computational-wise? Please raise up your hands. Okay, pretty much everybody. That's great. Second question, how many of you or your company are running those workflows using one of the public cloud service provider, or either partially or entirely? Please raise up your hands. Okay, quite a few. Great, thank you so much. So AI is definitely playing an increasingly important role, right, in general, in chem informatics and bioinformatics in general. So there's some interesting data from public research study. So 50 to 70% of the biotech or biopharma company are actually actively exploring computational or AI approaches, right, in their drug discovery or clinical analysis or research. And there's more than actually 200 startups recently founded in recent years focused on using AI and computational approaches in the early stage, especially in early stage drug discovery and development. What's interesting about these computational approaches is that they usually have a very sheer scale in computation. So we have some interesting internal data. So if we compare the actual high-performance computing usage of a computational scientist in this particular field to a simulation engineer in engineering, what we see is that on average, on a per user basis, you guys are consuming 20 times higher of the compute resources than an engineer in the engineering industry. So obviously, you guys are pushing the scientific boundary really, really hard. Kudos to you guys. So what that means is that high-performance computing also now becomes an important pillar, right, for supporting these kind of computational efforts. And interestingly, cloud has, I think, become the top choices, one of the top choices for tapping into the supercomputing power you needed in order to support this kind of efforts, and it's becoming increasingly adopted because there's a lot of benefits behind it, right? Because of the low cost of ownership, for your capital efficiency, which is particularly important for a lot of the early stage companies, right? Also, the high elasticity of your compute, right, for business agility, as well as the timely infrastructure upgrade, right, which is particularly important for you to be able to access state-of-art hardware timely to drive those HPC insights, right, and performance. And last but not least, post the COVID era, people started mostly remote working, right? So the high data accessibility, availability, and the security of cloud services provides the ideal support, right, for remote working and collaboration, which is also particularly important. However, these great benefits always come with great challenges. And as a matter of fact, for a lot of these challenges, the benefits, I would say the benefits actually buried behind these challenges for most of the time, meaning that if you're unable to address these challenges in the first place, you actually won't be able to realize those benefits. So let's look into these challenges in the first. Complexity, right? And cloud can be sometimes slow and very costly, always very costly to run. And it's super hard to optimize your usage on the cloud. And also, once you're running on your cloud, you adopt the cloud for your production environment, then it becomes super hard to optimize and to sustain that optimality. So let me dive into each of those to explain this further. So first of all, let's face it, cloud today, it's still very, very complex environment, okay? Um, the fundamental issue here is that as a computational scientist, we are domain expert, right? Most of the time, unlike software developers, we have very little experience and expertise about cloud. So as a result, sometimes we are forced to manage and set up a cloud environment, and that is very time consuming and distracting, right? So you either are forced to manage the environment on your own, or you have to work with someone else in a very inefficient manner to kind of set up and manage these cloud environments. So you definitely want to spend your valuable time on science and innovation, right? On innovating your algorithm, right? Building a better pipeline, driving the insight, looking into the data, right? Result, rather than managing these dirty work, right? So of course you want to have some kind of strong automation and hopefully some strong intelligence to help you move away from these dirty work. Second, I think, which is a bigger problem, if you go on any of the cloud service provider today, you find that their offering is very diverse and heterogeneous. For example, on AWS today, you can actually find more than 770 different infrastructure type and sizes that you can choose from. And you can still configure your memory, storage, networking configuration very flexibly. So in other words, for any type of a workload, you literally have thousands of different infrastructure configuration choices that you can choose from to deploy the same type of a workload. Now the question becomes, what is your optimal strategy? What is your optimal configuration that can really give you the best cost efficiency and time efficiency, right? Unfortunately, there's no transparency. A lot of time, you don't know the answer. And the bigger complexity here is that for different type of your workload, they actually require different configuration in order to get the efficiency. So unfortunately, there's no transparency. So a lot of time we're seeing people are flying blind. They choose a naive strategy, they run it, and as a result, they suffer from bad scalability, mostly really low cost efficiency. So we constantly heard our customer complaints about how expensive it is, right, to run something at scale in the cloud. Unfortunately, that's just most of the time that's a misconception. That's simply because very likely you're using cloud in not an efficient way, and as a result, you have that misconception. But of course, that's because there's no transparency, right? You're not aware of that a lot of time, and you don't know how to improve that condition. So you definitely want some smart solution, right, that could understand your workload and hopefully make decisions on this, optimize your workload automatically, right? That's the ideal case. Now, the third challenge is really about how do you make sure that you set up is sustainable, right? So cloud environment keeps changing. In the AWS case, driven by Moore's law, right? Every few months, you're going to see the next generation hardware technology comes out. The next generation CPU, GPU, DDR5 memory, right? InfiniBand, 400 gigabyte network. It keeps coming out, right? And because of that, cloud service provider keeps rolling out new infrastructure. Every few months, you're going to see new infrastructure gets introduced in the cloud. In theory, in last year alone, by the way, like in the case of AWS, they introduced 160 different new instance type and sizes just in 1 year alone. And that keeps happening. In theory, this is the beauty about running your computation intensive workload in the cloud, because you get timely access, right, to the state-of-art hardware. But in practice, we're seeing this as very big pain, because nobody keeps track of these things, right? As a scientist, even if you know these infrastructure, you still don't know, should I run it with my RNA sequencing pipeline, right? Is it gonna improve my cost? Is it gonna run it faster? There's no transparency. Not mentioning from the IT perspective, they've spent a lot of effort setting up a working environment, and they're reluctant to make changes, because once they make changes, they have to go through everything in order to validate a workflow. So in practice, we're seeing a very big gap and delay in the practical adoption of these great hardware. There's absolute great hardware out there, but people are not adopting them because of these challenges. So if you are facing these complexity, right, cost challenge or scalability challenges, right, or sustainability challenges while using the cloud, you must be looking for a solution, something that can fundamentally change the way that you run your computational workflow in the cloud. And what you're looking for essentially Fovus. So Fovus is the world first, what we call the AI-powered serverless high-performance computing platform. And we are official partner of AWS for HPC. So the idea here is really to use data-driven approach, to use AI approach to not only automate and orchestrate the entire cloud logistics, but also, more importantly, to optimize, to automatically determine, to optimize your HPC strategy and use that strategy to drive the automation. That is even more important, right? So as a result, not only as a computational scientist, you can finally say goodbye to managing these cloud hustles, but at the same time, you can be assured to achieve the best optimality as well as efficiency. And this is assured by our data-driven approach. And let me show you how does it work from a user perspective, step by step. So first of all, we provide you guys a very intuitive interfaces. We provide both a command line interface so that you can automate your workflow. You can even build Fovus into whatever the software tool that you build either internally or externally. So you can make Fovus the HPC backend. Okay, so you can automate your workflow. We also provide a very intuitive web interfaces for someone who doesn't write code at all, right? To be able to interactively deploy a workflow with just either a few clicks, right, with the web UI, or in a single command if you're using the CLI. The cool thing about our platform here is that in order for you to either deploy a large batch workload, could be AI inference training, any type of simulation, molecular dynamics simulation, docking, or even an actual pipeline, all you have to do is just to deploy your workload in a single command. You just need to tell us what is your workload. You just throw that in. You don't have to manage your AWS environment. You don't have to build any compute environment. You don't have to decide, right, what instance type and size to use in the first place. Nothing. You just throw in your workload. We do all the heavy lifting behind the scene, right? So we automate the entire logistic, and we determine what to use in order to best optimize your workflow. So the only thing that you have to do is just throw in your workload, as simple as that. So this is the reason why that is such a easy to adopt tool and easy to use and easy to scale and easy to optimize. And once we have your workload, there's multiple levels of optimization we do behind the scene in order to make the magic happen, right? So the first and most important thing that we do is we have a automated benchmarking framework. And in the case of running your bioinformatics pipeline, how does it work is we actually take your pipeline, okay, and we first analyze them, identify what are the top contributors, right, in terms of which processes in your pipeline are the top contributors to your time and cost. And then we separately create dedicated benchmarks, throw them into around each of those processes, and then we throw them into our benchmarking engine. And what the benchmarking engine do is for each of that process, it goes and benchmark it against all applicable HPC strategies within AWS to understand how different configuration choices quantitatively impact the time and cost for running each of your process. It will create a database based on that. Now, that's what we call the benchmarking profile. So essentially, we're creating dedicated benchmarking profile around each major processes in your pipeline. And that database is essentially what gives our system the visibility in terms of how to optimize your workflow, okay? And the strategy that we analyze here include many things, including the instance type size choices that covers different CPU, GPU models, memory configuration, storage configuration, networking configuration, even parallel computing setting in terms of how many CPU cores I should run it, right? Or even should I run it even with a GPU or no, those kind of things, right? So pretty much everything that matters to your time and cost for running your workflow, we benchmark them, understand what matters. Now the best part is that this is a free service and an automated service. So we bury the cost, you enjoy the benefits. Now once we have the benchmarking data, when you launch your real production pipeline or workflow, then this is where the magic happens. Because now we have the data, we'll automatically pull the data and use the data, right, to make prediction. And then on top of that, determine what is the optimal configuration at this particular time, right, to run your workflow or processes in the pipeline in order to minimize your time and cost. And this is really an optimization that is done in real time and also in an adaptive way. This optimization is done subject to the real-time availability and pricing dynamics in AWS, in the cloud, at a time, as well as the user objective. So as a user, you can even define how much importance I want to place on time minimization versus cost minimization. So our system will automatically drive different strategy to run it according to what really matters to you, right? So you can very easily get a different optimal strategy for your timing critical workload versus your cost sensitive workload. And it's very easy for you to just slide a bar, right? And then for the system to figure out what is the best way to run them. Another thing, that optimization that we do is particularly for you to help you address the availability challenge. One complaints that we heard all the time is when you run this kind of pipeline using on-demand resources, a lot of time you face scalability challenges because on-demand resources, if they are so high demanding, it is very difficult for you to be able to provision a large amount of them, right, to parallelize your workload. Especially if you're using spot instances or high demanding resources like GPU. They're super hard to get, right? If you're lucky, you might get a few, and then beyond that, sometimes become difficult to scale up. So we actually help you address that challenges by automatically distribute your workload across a list of multiple strategies. But the best part is that the strategy is all driven, data-driven. It's actually based on your benchmarking data. We analyze them. We figure out based on the predicted time and cost, we figure out, okay, which one is the most optimal strategy, which one is the second, third, fourth, right? We can build that list, and that list looks very different for each type of your workload, right? Because it's purely driven by the benchmarking data specific to that type of workload. And then we start distributing workload with the top strategy. As long as we can distribute, right? We find as many available resources, distribute across them. And once we exhausted all the availability, if you still have more tasks pending, we automatically go to the second optimal strategy, further distribute, so on and so forth, right? So until we have all of your workload running in parallel. So this is a very effective way, right, to significantly increase availability, help you scale easily, scale up your compute fleet, the size of your compute fleet, to make sure that you get a really short time to insight, right, but massively parallelize your workload. And again, the best part is that you don't have to determine what's the configuration in this list, right? This is pure data driven, determined by benchmarking data, and it's going to be different for each type of workload. We provide this optimization. So overall, this helps you significantly reduces your time to insight while still making sure this is cost efficient because this is all data driven. Another interesting optimization we do is we automatically help you leverage spot instances. And for those of you who are not familiar with spot instances, these are the idle resources in AWS where the cloud service provider actually marked down the price because they're underutilized so that you can use them with a significant discount. But the trade-off here is that they don't assure availability and the integrity of your result. If someone else wanted to pay for higher price to use them, they will terminate your job and give it to someone else to use. So there's always a probability that your workload will be interrupted and make them really hard to be used, especially for HPC workload, because their pricing is going to be highly dynamic based on the supply and the demand in real time in any of the regions and zones locally, as well as you have to manage your interruption, right? If interruption happen, you have to do something about it, rerun your workload, right? Manage that. So, and that kind of complexity around managing this kind of provisioning makes them really hard to be leveraged. So we have an automated system that automatically analyze the spot pricing and availability, right? And we also have your benchmarking data. So we use this information to predict what is the expected time and cost, right? If we were to use this spot strategy to run your workload, and we run this strategy, and then we further distribute them across each strategy, right, as I showed. So effectively, not only we can very smartly leveraging these resources to further reduce your cost, but also we ensure the integrity of your result. Once interruption happen, we automatically requeue your job, find another spot instances that turn out to be optimal, and then automatically resume the computation by restoring your computation from the last saved checkpoints. So if interruption happen, you don't have to redo your computation from scratch. We actually checkpoints your data and then restore the computation, so you don't lose any computation, very effectively utilizing these resources. Now you may ask me, what if the pipeline that I'm running doesn't natively support checkpointing, right? There's a lot of pipeline like RNA-seq, serverless pipeline. They don't have native support to save checkpoints. So in other words, for those processes, if you use the spot instances, once the interruption happens, you have to rerun the entire process from scratch and make it really awkward to actually use spot instances. No worry, so we get it covered. So we actually provide the capability of automatically memory checkpointing your application status. Your application doesn't have to natively support it. We actually insert the system services that provides the capability to checkpointing your execution status of your application, including your memory data, including your runtime contents. We get you covered. And the best part is that you don't have to change your code at our runtime environment. If this is a Nextflow pipeline, there's no change needed on your side. We automatically insert these capability. So essentially, we make sure that we periodically checkpoints, right, as well as upon interruption, right, or a out-of-memory error, make sure that we save these checkpoints, right, and then we'll be able to find another instances, resume the computation from the last saved checkpoints automatically. So you can very effectively utilize spot instances regardless of interruption, as well as if out-of-memory error happen, we'll retry it, and you don't have to lose all of the computation that already finishes. You can resume from the last saved checkpoints. And this is a very nice feature that makes sure that you can leverage these resources, right, idle resources, super efficiently. The last but not least optimization we do, which is pretty interesting, because now we have the automated optimization, we have the benchmarking capability, and they run in a closed loop form, right? So now what we can do is automatically upgrade your HPC strategy. As AWS is rolling out the new infrastructure, the next generation CPU, GPU, right, they become available, we automatically detect them, and we upgrade your benchmarking data, right, by running additional benchmarking to understand how does it work for your workload. Is it cheaper? Is it faster? It's sometimes both, right? As long as that's the case, the next time when you deploy your workload, will automatically switch your strategy to these latest infrastructure without you needing to upgrade your code. We manage all that. So this is a very nice feature to make sure that you can always leverage the state-of-the-art hardware to drive your performance, but without you needing to change any of your workflow, so that we can make sure you can make sure your team will be keep your team ahead of the game, essentially. Okay, so let's look into some real-world example and see what are some of the real-world impact. So this is a case study of running RNA sequencing pipeline, the open source NF core version of it, and this is using the test full profile, which I think had a pair of input samples. I'm curious, by show of hands, how many of you guys, your company are running some version of RNA sequencing pipeline in your company? Please raise up your hands. Okay, a lot of you guys. You might like this case study. So the interesting thing is that if you look into the benchmarking data that we collected by benchmarking this pipeline, to try to see, okay, what does the performance of these processes are really bounded by? And these are the top contributor, right, of time and cost, major processes in this pipeline. You see that these processes have such a different characteristic. Some of them are compute bounded, some of them are memory bounded, some of them are I/O bounded, and a lot of time it's a combination of those things, right? So what this indicates is that you really need a very different configuration to run different processes in this pipeline in order to be time and cost efficient. But unfortunately, most of the time we're seeing people running these pipelines using a naive strategy. They don't really optimize, right, that particularly for each processes. And that's where the inefficiency comes into the picture. So these are some of the prior case study published running this with on-demand resources. This is not using spot instances at all. These are only on-demand resources, right? So as you can see, if you run with AWS native batch solution without much optimization, the cost is pretty high, $97. Now there are some solution out there to provide some kind of optimization, either optimizing your I/O performance or a memory optimization. But again, this solution applies a fixed type of optimization on your pipeline, regardless of what you're running, right? They always apply the same type of optimization, regardless whether it's really I/O bounded or memory bounded. Of course, it helps bring down the cost, right, for those processes that happens to be I/O bounded or memory bounded. It brings further down the cost to between $30 to $88. But then the question becomes, is that really optimal? The answer is no, right? Because again, this is not optimized per process according to your workload characteristic, right? This is just generic optimization. Now, the big difference with Fovus is that we analyze your pipeline, identify what are the major processes, what really matters for optimizing them, and then we build a particular optimal configuration around them based on data, and then deploy them automatically to make sure each of them gets its own optimization. So if you do that data-driven optimization at a process level, right, it makes huge differences. You can significantly reduce your costs, right? You can even, this is, as comparing these solutions, this is almost 70 to 85% of cost reduction. And I think this is just a good illustration of how much waste you actually could have for running your pipeline without much optimization in the cloud. Now, very similar story if you are curious about what if you use spot instances, right? Again, these solutions leverage spot, but again, not in a data-driven optimal way, right? Versus Fovus, not only checkpoints your memory data, make sure that when interruption happen, we restore your computation, right, effectively, but also making sure the spot instance that we use and the configuration around them are actually optimized based on your processes, right? And again, that makes a huge differences. Very consistent, about 80% reduction, 80 to 85% reduction as comparing to other solution. So I think overall, there's two interesting insight here. The first interesting insight is that as comparing to a non-data-driven optimization, you can in general cut down 70 to 85% of your production costs. And what it means is that for the same budget, you can essentially run for at least 4 or 3 times of more workloads if you are using those resources efficiently. Second, what is really interesting here is that, as you can see, if you do that optimization, you can really run even with on-demand resources at a lower price as comparing to a spot resources. So what it means is that you can essentially run your on-demand resources and still get a really good availability. You don't have to worry about availability of a spot resources. You can essentially run with on-demand at a super high efficiency and scale it really well, okay? If you do that on Fovus. How much time? Okay, so I'll go really quickly. So we also have some other case study. Our platform not only run bioinformatics pipeline, but also we run any type of batch workload. So this is actually a molecular dynamics simulation. And just to be quick here, with optimization, without optimization, we can effectively scale your compute fleet to hundreds of GPUs easily on demand, and making sure that these are spot GPUs that are super efficient for running your workload. So overall, you can achieve more than 100 times reduction in time to insight while achieving 85%, right, reduction in cost. Very similar story for another case study. This is actually a high throughput workload screening for 500 million ligands running in multiple stages of processing. Again, similar story, with without optimization, up to 100 times of time reduction and more than 80% cost reduction. Given the time limit, I think I'm not gonna go detail into all of these case studies, but I would suggest you to go on our website if you are interested in looking into the result of this case study. But essentially, what you can see is that for some of the commonly used bioinformatic pipelines and computational chemistry or biology tools, what are the best efficiency that you can achieve on AWS with data-driven optimization running with Fovus? And a lot of time when we show these information, so for example, OpenMM for molecular dynamic simulation, AlphaFold for protein folding, BOWS, right, 1 or 2 for protein folding. A lot of time when we show these data in terms of the cost and time efficiency you can achieve, the response we get from readers or customers is that, okay, this is hard to believe. Is that real? Is that true? And our answer typically is, oh, give it a try. Try it yourself. And that's when you see the differences. So hopefully that gives you an overview about our platform capability and what are some of the benefits that you can expect if you adopt a solution like this, right, to optimize your cloud configuration, infrastructure configuration, HPC strategy automatically. Just to summarize it, we are the world's first AI-powered high-performance computing platform. We largely, at this point, help customers optimize their bioinformatic pipelines, as well as their batch workflows, computational chemistry and computational biology, help them save time and cost. We do offer free trials right now. You can do a POC or pilot just to see how much benefits you can get with us for free. So if you want to get more information, go on our website, schedule a demo with us, or go to our booth. We are at booth 49. We'll make sure that we get your question answered. Thank you.